Good day to my audience. Today I'm going to present my final year project proposal. My research title is Study on Bacterial Cellulose on Antimicrobial Food Packaging. My name is Wong Yi Hui. So today's topic include introduction, problem statement, objectives, hypothesis, scope of limitation, literature review, methodology, budget, and also research plan. So come to the introduction. In food industry, food safety has a high priority. So in order to be able to guarantee the consumer a safe product at time of consumption, producer focus on effort to inhibit the growth of microorganisms in the food product. Besides, there is also demand for eco-friendly material, which means biodegradable packaging film. To preserve the food quality of the product, food industry have focused to the possibility of developing degradable packaging that possesses antimicrobial properties. One of the natural packaging material is bacterial cellulose, which is synthesized by bacteria. Besides, there are many antimicrobial preservatives that can be incorporated into the packaging material. One of the most common type is potassium sorbate. Coming to the problem statement, in food industry, petrochemical-based polymer, which is plastic, are the materials is the most frequent use for packaging, but their non-biodegradable property result in environmental issue, for example, water pollution, landfilling insufficient for the disposal of plastics. So next problem statement is the shelf life of food. Consumer is demanding for food with minimal process. However, minimal process and reasons tendency of market is to minimize the chemical usage in food. The objective of my research is to synthesize a new biocomposite material containing bacterial cellulose and PVA with potassium sorbate incorporated as an antimicrobial agent. To evaluate the antimicrobial efficiency of the new biocomposite film, and the next objective is to suggest suitable food type for synthesized active film. The hypothesis of my research project is I assume that there is no chemical reaction between the active compound and the film. Also, the mechanism is through diffusion. Therefore, the diffusivity of active agent in the packaging film is assumed that it is much more smaller than that in the film, and volume of the food layer is very large compared to the volume of the packaging film. For the scope of limitation, for my research, the method that I use to synthesize new biocomposites is through deep coating method, which means the bacterial cellulose is in pellicle form and it is deep coated into the antimicrobial agent. Besides, to study the efficiency of the antimicrobial properties, the method used will be agar-disc diffusion method. In this method, the area of inhibition zone is the parameter to measure the effectiveness of the tested film. After reading some journal articles, bacterial cellulose is chosen to synthesize using histidine strain medium and with the pure strain Acetobacter solanum. BC is incorporated with polyvinyl alcohol, as some researchers found that it gives a better quality of film, which consists of tensile strength associated with enough elasticity, which to allow for greater flexibility. For antimicrobial agent, potassium sorbate is chosen as the antimicrobial agent as it is most commonly used in the market, and potassium sorbate will be mixed with PVA solution and later will be deep coated by using bacterial cellulose synthesis before, and after that the new composite film will be freeze dry for cross-linking to happen. For methodology, there will be three main steps to prepare this experiment. First is the preparation of bacterial cellulose using Acidobacter which, as mentioned before, it is cultured using history strain medium and incubate at 28 degrees Celsius for 3 days. After that, the thickness of the bacterial cellulose dry film will be evaluated. Next, the preparation and evaluation of bacterial cellulose containing PVA and potassium sorbate. Firstly, the antimicrobial activity of the potassium sorbate will be tested singly using which just immersed in filter paper. After that, the minimal inhibitory concentration of potassium sorbate will be tested using E. coli. Come to the most important part of the experiment. To prepare the new biocomposite, firstly PVA is dissolved in hot water, and after that potassium sorbate powder is added into the PVA and mixed well. After mixing well, bacterial cellulose film synthesis before is immersed into the mixtures, and it is freeze-dried at -20 degrees Celsius for 24 hours. To sterilize the film, it is washed with ethanol, and to dry the film, it is dried in oven at 50 degrees Celsius for 12 hours. To evaluate the antimicrobial efficiencies of the new film, agar diffusion test is the method that used in this project. So the film is incubated at 37 degrees Celsius for 24 hours with the petri dish inoculate with Escherichia coli. The parameter is the inhibition zone diameter around the film were measured by antibiotic zone reader. Besides, we also determine the potassium sorbate contained in the bacterial cellulose film. To observe the morphology of the new film, it is we use scanning electron microscope to observe the morphology of the film. The budget of this project is there is only two materials that need to purchase, which is PVA polyvinyl alcohol and also potassium sorbate. PVA is purchased from Sigma Aldrich and potassium sorbate will be purchased from Personal Formula Resource. The total price will be 270 ringgit 30 cents. For this research plan, there is about 8 months for this project to complete. Firstly will be literature review and followed by proposal presentation, which I'm doing now. After that, at the end of this month, there will be experimental activity started, and collecting data will be followed by the experiment activities, and data analyzing will be carried out when collecting data. Before I write the report, I will investigate the shortcomings which occur during the experiments. So at the end of the May will be estimated at the project completion for this project. That is all from me. Thank you for your attention.